Hello, welcome everyone. Today we are doing maths, and in maths we are doing graphs. That is the linear graphs on line that we are doing. And definitely we'll be doing how to solve them algebraically as well for straight lines. But today we are only specified to the straight line graphs. So let me see how can we detect this equation of a line, intercept, roots, everything from the graph. You are pretty much aware with this. These are two axes. This is your y-axis and this is your x-axis. Now the equation is also there for x-axis and y-axis. If I talk about x-axis, every value on x-axis, there is a constant value of y which is 0. If I take any point, suppose this is 1 comma 0. If I pick this will be 5 comma 0. Here if I pick this will be minus 1 comma 0. So you can clearly see every time 0 0 0 the value of y is constant, and this is the reason the equation of x-axis is actually y equals 0. Now this is the most common mistake by the students. They think that this is x-axis, so the equation is going to be x equals 0. No. How can it be x equals 0? If on x-axis you will get the different values of x. Just like I told you here, if you pick, it will give you 1 comma 0. Here this will give you 5 comma 0. So here the value of x is changing. The value of y is 0, and that's why the equation is y equals 0. Similarly, if I pick any point here, this will be 0 comma 1, here 0 comma 4, here if you pick 0 comma negative 1. So value of y is changing, but throughout the y-axis the x is 0, and this is why the equation of y-axis be x equals 0. This is important to understand. Don't just learn and cram these things. Just try to understand why the equations are like this. So I can write that equation of x-axis is y equals 0, whereas equation of y-axis is x equals 0. Now the second part is equation of a line that are parallel to x-axis and y-axis. Suppose I'm drawing the equation that this is the straight line, and you can see this is parallel to your y-axis. Let me just name it. This is y-axis and this is x-axis. Similarly, y and x. This green line represents a line which is parallel to y-axis. Suppose this coordinate be a comma 0. Like this straight line is passing through a comma 0. Now, if I pick this point, maybe this point be a comma 1, or if you are a little bit confused with a represents any number. Here that can be 2. Suppose 2 comma 0 be my point. On this straight line throughout, if I want to find the points, the coordinates, this coordinate is going to be 2 comma 1. This will be 2 comma 2. This is 2 comma 3. Here 2 comma negative 1, and so on. So you can clearly see in this straight line the value of y is changing from negative 1 to 2, 3. It keeps on changing, but what value is remaining same? The value of x is remaining same. 2 is same. So what's the value of 2 here throughout? It's 2. What's the value of x here throughout? It's 2. So x is equals to 2, because throughout this line x is equals to 2. If you're a little bit confused, you just go back and see the equation of y-axis. I said that throughout this straight line, the value of x is 0. If you pick this one 0 comma 1, 0 comma negative 1, 0 comma 7, so you can clearly see throughout the value of x is 0. What's the value of x? X is 0 throughout this line, and that's why it has equation x equals 0. Similarly, if I see this one, I can see that throughout this straight line the value is 2 for x, and that's why the equation will be x equals 2. Similarly, if this coordinate is 3 comma 0, now the equation will be x equals 3. Why? Because if it is passing through 3 comma 0, this coordinate will be 3 comma 2, suppose this is 3 comma 7. So we can clearly see that throughout this straight line the value of x is constant, which is 3. And if I represent this with a represent any number, it can be 1, 2, -1, whatever. A generalized one is a comma 0. That means if I pick here, this will be a comma 1, this will be a comma, suppose 4, this comma a comma 6, so on. So throughout this straight line the value of a remains same, and this is the value of x. So I can see that throughout this straight line the value of x is a, and that's why the equation is going to be x equals a if this coordinate is a comma 0. So here I wrote the explanation as well, that the equation of a straight line parallel to y-axis is x equals a if the line passes through the coordinate a comma 0. Because throughout this straight line the value of x coordinate is same, which is x equals a, and that's why the equation is x equals a. Similarly, I can say if a straight line which is parallel to x-axis, and this is suppose passing through this coordinate which is 0 comma a. Now throughout this straight line the value of y remains same, because if I pick this point, this is going to be 1 comma a. If I pick this point, maybe this is 4 comma a. If I pick this point, maybe this is -2 comma a. So you can clearly see that throughout this straight line the value of x is changing, whereas the value of y is constant, which is a. So I can say that equation of this straight line is going to be y is equals to a. So the line which is parallel to x-axis, don't learn it like this, that okay, line parallel to x-axis is going to be y, that is opposite will work. No, just try to understand why this equation we are getting. It's simple, because throughout that line the value of x is changing, whereas y is constant, which is a, and that's why the equation is y equals a. And similarly, I have written the explanation for this line as well, that why the equation of a line parallel to x-axis is y equals a if that line is passing through 0 comma a. Now moving on to those equations of a line that are a little bit different. They are not parallel to any particular x-axis or y-axis, if they are just inclined. So let me see how can we find it. This one, we have to calculate the equation of a straight line, any line, not necessarily parallel. It can be inclined, and because it's inclined, so there is a word that's called slope or gradient. So this angle that it is making with the x-axis, this gives the slope or the gradient. Actually tan of this theta will give you the slope, but the syllabus has the coordinate form gradient. In short, gradient or slope means how much inclined your straight line is with x-axis, how much angle is it making. You're calculating its steepness, and gradient can be calculated as change in y over change in x, which means suppose I'm here at this point and I want to reach to this point. So basically, if I want to know the steepness of anything, how steeper is it, I need to walk through it, walk on it, so I can get to know. And similarly, what I'm doing, I'm just walking. So if I want to move from A to B, either I can go directly like this, but this is a straight line that is plotted between x-axis and y-axis. So it would be like this, that first I'll move in x-axis and then I'll move in y-axis. And by doing so, I can ultimately reach to A. So how much have I moved in x? That means this value of x, and how much I have moved in y, that will give me the gradient. So change in y over change in x will give me the gradient. Or in a coordinate form, this can be given as, suppose the coordinate of x, A is x1, y1, and coordinate of B is x2, y2. So it would be change in y is y2 minus y1, because you have moved from y1 to y2. So it would be y2 minus y1. And similarly, change in x would be x2 minus x1, and this will give you the gradient. So gradient is very important to know the equation of a line. The standard way of writing equation of a line is y is equals to mx plus c. In this, m represents the gradient that we were talking about, and c represents the y-intercept. So in order to know the equation of a straight line, two things are important: gradient and y-intercept. So this is y-intercept. Clearly, y-intercept means the straight line when it cuts the y-axis. This is the point where straight line is cutting y-axis. So this would be your y-intercept. So let me see how can we exactly calculate the equation of a line if it's plotted on a graph. See, this is a straight line. If you want to know the equation of a line, very first thing is write down y is equals to mx plus c. Our first aim is to calculate the gradient and then y-intercept. Clearly, I can understand here that y is this. Your straight line is cutting y-axis at 4. That means intercept is this, coordinate is 0, 4, but the value of y is 4 here. This whole value is actually 4. So, in place of c, I can write 4. Value of c is 4, I get to know. Now, the second thing is to calculate the gradient. So, pick any two values. You can pick any two values. Always, you'll get the same value. So, the gradient of a straight line is always constant. Let me pick this one. So, this one is negative 2, 0. So, gradient is change in y over change in x. So you can take anyone as x1, y1 and x2, y2. I'm taking this one as x1, y1 and this two as x2, y2. So x1 first is y2 minus y1. So here 4 minus 0 over x2 minus x1, 0 minus 2. So answer is 4 over 2, gradient is 2. We have the value of gradient, we have the value of y-intercept, just put the values, that's all. So final equation is y is equals to 2x plus 4. This will be the equation of the straight line if it's given on a graph. Now let me do one more question on the same. Same, whenever you want to calculate the equation of a line, first write down the standard equation, which is y is equals to mx plus c. From the graph, only you have to calculate two values because m and c are constant here. So that's the value that you have to calculate. So for here, c is the y-intercept and clearly you can see that it's cutting y-axis at 5. So c is going to be 5. It's easier one. Second is take any 2 points. As I told you, if you pick any 2 points, you'll always get the same answer. So let me pick this point. This point is 0, 5 and this point is 7, 0. And now change in y over change in x. You can pick anyone as x1, y1 and x2, y2. So change in y would be gradient is change in y. I'm taking this one as x1, y1 and this one as x2, y2. So y2 minus y1, 5 minus 0 over x2 minus x1, 0 minus 7. What I did, let me write it down if you have any confusion. x1, y1 I have taken as 7, 0 and x2, y2 I have taken as 0, 5. So clearly y2 that is 5 minus 0, x2 minus x1, x2 is 0, x1 is 7. So this will give me answer is negative 5 over 7. Obviously 5 minus 0 is 5, but 0 minus 7 is negative 7. So negative 5 over 7 will be the gradient. Now put the value, that's all you have to do. So y is equals to negative 5 over 7x plus 5. That's the final equation of the straight line. Now let me see one more that you have to actually keep in mind, that this is going to be the equation of the line. Let me discuss those two equations. These are those two equations that are generally, even like if you go in a higher standards and you will see the transformations, reflection, if you study, you will find this straight line very common. See, let me explain it with the traditional way, that is by y is equals to mx plus c. Here this is 0, 0. You can pick this one as 2, 2, and here it would be 8, 8. You can pick any 2 points. So change in y over change in x would be, gradient is going to be 8 minus 2. I have taken these 2 points, this one and this one. So 8 minus 2 over 8 minus 2, 1. So it doesn't matter. If you will pick any value, you will get the same gradient, which is 1. So m is 1, c is 0. Final equation is y is equals to x. And this is the most common. This is the equation of y is equals to x. It has a gradient 1 and it passes through the origin and equally inclined to both the axes. That means it will make 45 degrees to this one and 45 degrees to this one. That is always the equation of y is equals to x for this line. Moving on to the next one, this is almost the same, only there is a minor difference. Here the minor difference would be same. I'll start with y is equals to mx plus c. Clearly c y-intercept is 0 because it's passing through origin. C is equals to 0. For gradient, change in y over change in x, let me take this is 0, 0, and let me pick this one 8. So change in y over change in x would be 8 minus 0 or minus 8 minus 0. This would be minus 1. So here it will be y is equals to minus x and plus 0. So this is the equation of a straight line, y equals negative x. I mean this straight line is y equals negative x and previous one was y equals x. These are very two important straight lines. Now let we see some questions where we have to compare the gradients of or find the gradients of different straight lines. See this one, if we have to compare the gradients, here the numbers are not given. Unlike the previous graph, you can see the numbers are given. Here there are no numbers given, so only we have to rely on the boxes given. Gradient, that same, change in y over change in x. So let me just write down, gradient is change in y over change in x. Now in this case, I just need to take only 2 points, any 2 points. So let me just pick this point here. Let's say this point, and let's say this point. So in order to move from here to here, like from here to here, how much I have to move? How many boxes? 1, 2, 3, 4, 5, 6. 6 boxes towards left. So what I did, I moved 6 boxes towards left. That means this is negative 6. And now I need to move upward. How much? 1, 2, 3, 4, 5, 6. I moved 6 boxes upwards. That means plus 6. So change in y is plus 6 over change in x is negative 6. It's negative 1. So gradient of this is negative 1. This is, let's say, part A, and we have calculated for AB negative 1. Similarly for part B, I have to pick 2 points. Let me say one point be this and another point be this. So how much I have to move? I have to move 1, 2, 3, 4, 5, 6. 6 boxes. So here 6 boxes. That is plus 6. And now I need to move upwards. So 1, 2, 3, 4. 4 boxes upwards. That is plus 4. So gradient is change in y over change in x. And how much change in x is there? Plus 6 boxes, and y is plus 4 boxes. So I would write 4 over 6, that is 2 over 3 be the gradient for part B. For part C, again I'll be doing the same thing. That means pick this point and pick another point. In order to move from one point to another point, I can do anything. In this case, first I chose y, x-axis, then I chose y. That means first I moved horizontally, then I moved vertically. Instead, you can move first vertically, then horizontally. It will give you the same answer. That means here I'm changing my approach. First I'm moving like 3 units downwards. So change in y would be negative 3 over, then I moved how many? 1, 2, 3, 4, 5, 6, 7, 7 units in positive direction. So these are 7 boxes and these are 3 boxes. And my gradient would be negative 3 over 7. Moving on to the next one. Here it says compare the intercept. I haven't mentioned the x-intercept or y-intercept. So because as they have described intercept, so let me find both the intercepts. First, let me write y-intercept is where straight line cuts y-axis, and that I have written earlier as well. Where straight line cuts y-axis. Similarly, x-intercept would be where straight line cuts x-axis. Now here, for, let me say this be part A, where it's cutting y-axis at 4. So I can say y-intercept is clearly 4 and x-intercept is negative 4. For part B, here I can't see where exactly x is cutting, like this a straight line is cutting x-axis. So what I can do, I can just extend this one. If I just like extend this one like this, ultimately I'll get that it's cutting at 8. So here I have to write that since straight line is not cutting, so we have to extend it. On extending, we'll get x-intercept be negative 8 and y-intercept be negative 4 because it's cutting y-axis at negative 4. Moving on part C, it's cutting, there's no chance that you can find x-intercept in this case, so I'm just leaving a blank and calculating only y-intercept for this one, and y-intercept is where it's cutting y-axis, that is at 6. So this is the answer. Now let me see how can we, this is all that we have concluded from a graph given. We have calculated the equation of a straight line. We have seen that how the intercept can be calculated, how the gradients can be calculated, how in a graph where the points are given and in a graph where nothing is given. Like this is a blank graph, the previous one, only the boxes are there. Now let me see how can we plot a straight line on a graph. It's given as plot a graph of y is equals to 3x plus 4. This is a straight line equation of a straight line given and you have to plot it on a graph. What you need to do is you just need to make a box. Plotting any graph, the simplest way is to draw a table and then find the coordinates accordingly and plot it on the graph. That means, let me draw a table here. See, now what you need to do is x is called independent variable whereas y is called dependent variable. It's on you what value of x you want to pick. You can pick any one, -2, -3, 1, 2, but I would suggest you to at least take equal number of negative positive value or at least take 1 or 2 negative values. So best is to plot a straight line. Specifically for a straight line, take 5 values, 2 negative, 2 positive, or 1 0 you can take, or 3 negatives, 2 positive. So here I'm taking -4, -2, 0, 2 and 4. When I put, because these are the values of x I have selected, I need to substitute. So first equation is y is equals to 3x plus 4. So in place of x I need to substitute -4. This value I have to put first. So 3 into -4 plus 4. Answer is -8. So it would be -8. Now y is equals to -2 into 3 plus 4. So this is -2. Answer is -2. Similarly, y is equals to 3 into 0 plus 4, it's 4. Then y is equals to 3 into 2 plus 4, which is 10. And finally y is equals to 3. I'm doing nothing, I'm just substituting the value of x, what I have selected. Again, it would be on you what value of x you want to select, completely on you. My suggestion is at least take 2 values of negative and 3 values of positive, or you can take 0 and 2 values of negative, 2 values of positive. In this way you can evenly distribute. Y is equals to 3 into 4 plus 4, which is 16. So here it's 16. Now let me just plot it. X is negative 4 and y is negative 8. So x is negative 4, y is negative 8 here. X is negative 2, y is negative 2 here. X is 0, y is 4 here. X is 2, y is 10 here. And at 4 it's going 16. That's beyond this graph that we have. So let me just end it and join this together. On joining, we got a straight line like this. So this is how you can plot a straight line. Similarly, you can do the same method for the other graphs as well. Now it says complete the table. In this they have already given the table, even the values they have given. We need not to select the values from our side. And it says plot the graph of 3y equals 9x minus 6. So here just plot it and complete the table. So definitely first thing is we need to complete the table. For minus 4, let me just simplify this. Equation of a line would be better. Equation of line is 3y is equals to 9x minus 6. Because we want to calculate the value of y, let me make y the subject, and that we can do by dividing both the sides by 3. So when I divide both the sides by 3, this will become y is equals to 9x minus 6 over 3, or can be written as 3x minus 2. Now it would be much simpler. We can easily calculate. First put y equals negative 4. So 3 into negative 4 minus 2, which is minus 14. Then y is equals to 3 into negative 2 in minus negative 2. 3 into negative 2 is negative 6 minus 2. Answer is negative 8. Y is equals to 3 into 0 is 0. Minus 2 is minus 2. It's just basic substitution I'm doing. Y is equals to 3 into 2 minus 2. 6 minus 2, 4. Y is equals to 3 into 4 minus 2. 12 minus 2, 10. Now put these values. See, first one is just going beyond this. Like at minus 4, it's going minus 14 somewhere, like it's above. So we are not plotting it here. From negative 2, I'm plotting because negative 2 at x equals negative 2, y is negative 8. So at negative 2, y is negative 8. First point be here. Second, at 0, x is 0, y is negative 2. It's here. X is 2, y is 4. Here. X is 4, y is 10. It's simple. X is 4. If you are a little bit confused how I'm plotting, x is 4. So that means just draw a straight line like this. And y is 10. Where they are intersecting? This is the point they are intersecting. So this is the last point. Now we need to join them together. It will give me a straight line. This is our required straight line. So basically that's it for this graph portion. In the next part we'll be completing the graphs. That is, we'll see the real life graphs. How can we calculate the intercept and the gradients? Even we'll introduce about the perpendicular lines, and also how can we calculate the equations of a line algebraically. That we'll be doing in the next class. So that's it for today. Thank you. Have a great day.